Good afternoon, everyone. You are welcome to the Dawn's Consult. Today, I'm bringing you a question that has to do with the periodic table and the electronic configuration. This is a wire question that I've grafted out, and I want to see how we can use this question to understand the concept of the electronic configuration and periodic table. Let's have the question. The question says, the electronic configuration of 5 elements represented by the letters P, Q, R, X, and T are indicated below, and we are given their respective electronic configurations. The question now says, without identifying the elements, state which of them 1. Belongs to group 6 in the periodic table, 2. Is strongly metallic in character, 3. Readily ionizes by gaining 1 electron, 4. Contains 2 unpaired electrons in the ground state atom, 5. Readily loses 2 electrons during chemical bonding, and 6. Does not participate readily in chemical reactions, and lastly is an S block element. Alright, so when you see a question like this, how do you attempt them? So let me see what we do best here at the Dawn's Consult to simplify every question. So follow me, let's go. All right, the first one says we should identify the element that belongs to group 6 in the periodic table. Now, if you remember one of the video I've sent before now, so if you have not seen it, go and watch that video, how we can identify elements and the group they belong. There are 2 methods. You can use the shell method. You can use the shell. If you are using the shell, the number of electron at the valence shell, gives you the group that element belongs. And if you are using this very one that they gave us, so you can decide to put all this one into their shells for you to identify them. But if you are the type that can memorize quickly, you can use this. I remember telling you that if you have 1 electron at the s orbital, that belongs to group 1. If you have 2 electrons at the in the s orbital, that belongs to group 2. Then if you have 2 electrons in the x orbital and 1 in the p orbital, that's group 3. Then if you have 2 electrons in the x orbital and 4 in the group in the p orbital, that belongs to group 6. So now look for that. So you can see that if you check properly, you will see that it is Q that have 2 electrons in the s orbital and have 4 electrons in the p orbital. So the answer to that first question that says belong to group 6 in the periodic table, the answer there is what? If that is letter Q. I hope you understand that. All right. The second one says, which of the elements is strongly metallic in character? Now, what are the characteristics of metals? 1, they ionizes, and when they ionizes in positive what? They form positive ions. All right, and they readily donate electrons. So which of these do you think will donate electrons? And remember that elements with 1, 2, and 3 electrons at their valence shell will readily donate. All right, they will donate. So which of these has 1, 2, or 3 electrons at their valence shell? Such will have metallic. In fact, if there are 2 that have that, remember that the group 1 elements have higher metallic character than group 2 and than group 3. These are the things you watch out for. Should you have 3 metals there, which one belongs to group 1? The ones that belong to group 1 will have higher metallic character than the group 2 than the group 3. These are the points you will use to answer that question. So which of these will have 2 electrons at the valence shell? If you look at this now, this will be, if I want to rewrite this in shells, this will be 2, 4. Is that right? And this will be 2, 6. Hope you are following. The first shell we have 2 electrons, and the second shell and above we have 8 electrons. So these are the number of electrons here. All right, so this one will have these 2 electrons here and 6. So this one will have 2 and what? 8. Can you see it? This is the first shell and this is the second shell, 8 electrons. So X we have what? We have 2 8 and 2. This is 2, 8 and 2. All right. Then the other one we have 2, 8 and 7. So which of these now has 2 or 1 or 3 electrons at valence shell? You can see it is this one, and this is letter what? X. So the answer to that second question is what? X. Are we following? All right. Okay, the next one says readily ionizes by gaining 1 electron. Mind you, when we say electrons with 1, 2, 3 at the valence, element with 1, 2, 3 electrons at the valence shell, we donate. The one that has 1 electron, we donate to the one that has 7 electrons, and the one that has 2 electrons at valence shell, we donate to the one that has 6 electrons at valence shell, and the ones that has 3 electrons, we donate the electron to the one that has 5 electrons at the valence shell. What are they trying to obtain? That is the octet rule. They want to have 8 electrons at the valence shell to have what? Stability, for them to be stable. All right. So now the question says, which one we readily ionize by gaining 1 electron? So which one has 7 electrons at the valence shell? That was the one that will have 1 electron, and if you look properly, it is this one that has 7 electrons at the valence shell. So it will readily ionize by gaining 1 electron. So the answer to that is what? T. T is the answer to that question 3. All right. Okay, now let's go to number 4. Number 4 says, which one contains 2 unpaired electrons in the ground state atom? Ground state is when they have not ionized. That's what they mean by ground state, when it has not what? Ionized. So now what do you do? How do you get the unpaired electrons? Remember that x orbital, we have 1 energy level. P orbital has 3 energy levels. Are you with me? This will be p orbital that has 3 energy. They are all in s and p, so let's limit it to this one. And you know that according to Hund's rule, that when they pair, they will pair singly first, that when they pair singly before piling up. So let's take it one after the other. The p is what? The p has how many electrons here? 4 electrons. The p has 2 electrons in this one. So for that first one, the p we have like this. Okay, that will be for what? For p. All right. The one for q will have the p orbital, all right, has 4 electrons. So that will be 1. They say they go singly first before pairing up. 2, 3, 4. Is that right? That is 4. So then the one that have the other one is, this is for what? For q. Then the other one is for r. R has 6 electrons at the p orbital, and when they go singly, 1, 2, 3, 4, 5, 6. There's no unpaired electrons there. That is for r. Then the next one is for x. All right. The s has how many electrons at the p orbital? In fact, x did not end with p orbital. They are all satisfied. They will go to t. Look at the x. All the orbital levels are complete. X is complete here, S is complete here, P is complete, X is complete. All right. You know that P will have maximum number of 6 electrons. S will have maximum number of 2 electrons. You remember that? Okay. If you have problem with that, just put that in the comment section, or you private chat me so that I can put you through. All right. Now let's go to T. T has 5 electrons at the valence shell. So there will be, that was for T now. This is 1, 2, 3, 4, 5. So with these ones, which one have 2 unpaired electrons? With these ones now, which one have 2 unpaired electrons? P has 2 unpaired electrons. Can you see? Q also have 2 unpaired electrons. R, there's no unpaired electrons. T has only 1. So the answer to that question 4 is what? P and Q. P and Q. All right, let's go to question 5. Question 5 says, which one readily loses 2 electrons during chemical bonding? Loses 2 electrons. That means which one has 2 electrons at the valence shell? So from here now, which of these has 2 electrons at the valence shell? You can see it is X. that have 2 electrons. I've told you before now that the ones that have 1, 2, and 3 at the valence shell will readily lose it. All right. So the one that readily loses 2 electrons during chemical bonding is X. All right. Let's go to question 6. Said, which one does not participate readily in chemical reactions? Elements that does not participate readily in chemical reactions are the one that have stable electronic structure. That means the one that the valence shell is complete. If it have only 1 shell, it must be 2. If it has more than 1 shell, then the valence shell must be 8. So which of these has complete valence shell? This one doesn't have complete, needs 4 more. This one doesn't have, it needs 2 more. But this one has complete 8. This one still needs 6, and this one need 1. So the one that does not participate readily is the one that have complete electronic shell, and that is R. R does not participate readily in chemical reaction. So the answer to question 6 is what? Letter R. Are we following? Now the last one say which one is an S block element? How do you determine which element is S block, P block, D block? That is the last energy level. So which of these is the last energy level S block? That's what you see. This energy level ends in P. This is a P block element. This is a P block element. This is a P block element, and this one ends in X block. So this is S block element. This one ends with P. This is P block element. So the element that is an S block element here is S. That is the solution to this problem, and that is how simple this can be, and that is what we do here in the Dawn's Consult. We make chemistry very, very simplified. Very, very simplified. All right. If you have not subscribed to this channel, please do so now. Press that subscription button and follow up for more videos. Thank you. Please like this video and recommend to your friends. See you in the next episode.